We're back. Hello. Hello. We're back. Easter break is cut short. I'm very sorry, but here we go. All right. So today we're going to talk about permutation notation, which is a take on factorials. So here's the question, right? How many permutations are there if there are 22 things taken 6 at a time? So we're looking to generalize this, but if we're taking 6 things at a time, right? The first choice I got 22. The first place I got 22 choices. The second one, and this is non-replacement, obviously, right? Second one I got 21. Then there's 20. Whoops. Apparently break was a little longer than I thought it was. 19, 18, and 17, right? So now this becomes 22 times 21 times 20 times 19 times 18 times 17, which gives me a grand total of 53,721,360 choices, right? Just with 22 items and just choosing 6 at a time. There are over 53 million combinations there. All right, so if we're going to break it down, right, this is basically 22 times 21 times 20 times 19 times 18 times 17. Or we could say that it's 22 times 22 minus 1 times 22 minus 2 times 22 minus 3 times 22 minus 4 times 22 minus 5. And then we could say that this is n times n minus 1 times n minus 2 all the way down to n minus r. But the problem is that if we say that it's n minus r, then if our r is 6 right here, because this form right here, this is telling me that I have 22 and 6, where this is my n and this is my r. The problem is that then that gives me 16, but my last number here is 17, so I can't really work that out, right? So instead of saying that it's minus r, I'm going to say that this is n minus r plus 1, because that will get me to the term just before that. Right? So here's the general form, right? I have the number of permutations. This is the number of items that I have. This is the number of items that I'm looking to put in order. So this is going to be n. That's definitely an n. That is not an r. Very sorry about that. That does look like an r. This is n times n minus 1 times n minus 2 times n minus 3, all the way to n minus r plus 1. So when we do all that and we put it together, we get this general form, which is n factorial over n minus r factorial. All right? And this is going to be the n over r for that number of items and that number of places. So there are other forms of this where it is that I have it like this, right? Or I have it like this, or I have it like this. We're going to stick with this form here because I like this form right here. All right, so if I take this right here and I want to find this, I know that I have 12 items and I'm looking to put it into groups of 4. So that means I'm going to have 12 factorial over 12 minus 4 factorial, which is going to give me 12 factorial over 8 factorial. You should see where we're going now because we were doing these earlier in the year to get us used to it. So this is 12 times 11 times 10 times 9 times 8 factorial all over 8 factorial. Those are going to cancel. So I have 90 times 132. So 132 times 9. 132 times 9 is going to give me 18. It's going to give me 28. That's going to give me, so there are 11,880 combinations there for that permutation. All right, so pretty straightforward there. I hope you guys are doing well. I graded the tests. They are up. The only one who I'm waiting on is Joe Ramasco. If you could get that picture to me. I don't know if you're checking your email. Joe, come on, get on it, buddy. And we'll figure out where it is that we're going to proceed from there. All right, so this is permutation notation. I'll see you guys tomorrow. Out.